In this first video, we will be addressing the fundamentals of safety on primary lines, a topic that defines how this work should be carried out. Introduction to safety on primary lines. Safety in line maintenance. Primary lines is the absolute priority for every professional in the electrical sector. Every work shift in energized environments involves serious risks, from electrical arcs to falls from heights and injuries from moving objects. To reduce these risks, it is essential to combine three elements. 1. Technical knowledge. Understanding how primary lines work, their materials, structures, and electrical behavior. 2. Operational discipline. Following procedures and protocols to the letter without improvisation. 3. Safety culture. Assuming personal and collective responsibility for one's own safety and that of colleagues. Now, what are primary lines? Primary lines transport electricity at medium voltage ranging from 4 kilowatts to 34. 000 kW, kilowatts, from the substation to distribution transformers. These transformers then supply power to homes, businesses, hospitals, and schools, ensuring the electrical supply to entire communities. Their main features are installed on elevated poles or towers. They span long distances, crossing rivers, roads, mountains, and urban areas. Hence, every connection point is critical and requires precision and adherence to technical standards. Working on these lines means being exposed to potentially deadly risks. That is why understanding the physical structure of the line is essential. The materials used: conductors, insulators, hardware, grounding systems, and their protective function. Electrical behavior under different weather conditions and loads. There are electrical risks. Electricity is invisible, silent, and odorless, but its contact can be deadly. Risks include direct contact with energized conductors, indirect contact through tools, branches, or other conductive objects, electric arcs from proximity without physically touching the conductors, insulation failures in tools or equipment, adverse weather conditions such as rain, humidity, or wind, human errors from overconfidence, fatigue, or routine. Every preventive measure, no matter how small, can save lives. Check retention. Use the correct personal protective equipment properly and follow strict protocols. These are vital actions. Now, there's a safety culture. Safety culture is not just about wearing helmets, gloves, or harnesses. It is an attitude, a way of thinking and acting at all times. Safe work means taking care of yourself and your coworkers. Having a job, and if something isn't right, report any anomaly immediately and take the necessary time to do the job correctly. A strong safety culture reduces incidents, improves efficiency, and builds trust among team members. Now, there are universal safe work principles. The principles are to maintain the minimum safe distance. Never get closer than allowed to energized conductors. Work with energized lines only when necessary. Verify absence of voltage, never assume. Always measure and confirm. Follow established procedures. Rules exist because accidents happen before. Maintain constant communication with the team. Coordinate every move now. No job is so urgent as to take unnecessary risks. Now, there is personal protective equipment. Personal protective equipment is the last. line of defense against electrical and physical risks. They include a dielectric helmet with its chin strap, leather and insulating gloves with current certification, safety glasses or face shield, flame-retardant clothing, dielectric boots with non-slip soles, a harness with a double lifeline for work at heights. And before using it, inspect all the equipment. If anything is broken or expired, do not use it. Remember, your life has no replacement. For this, there is work planning. Planning means preventing before acting. Before climbing the pole or opening a line, assess environmental risks. Check weather conditions. Determine necessary tools and equipment. Analyze nearby vehicular or pedestrian traffic. Check for interference from branches, metal structures, cables. Complete the risk analysis form. A prior check can make the difference between a productive day and a tragedy. And there are real cases. Analyze previous incidents. This reinforces learning. A defective tool causes an accident, minor or serious. A poorly placed harness can cause a fall. Truly, a supervisor who skips the check increases the risk. Overconfidence is one of the biggest enemies of electrical workers. Each story reminds us that life is worth more than any repair or emergency to attend to. Now, there is a hazard assessment and prevention. After understanding the importance of safety and electrical risks, we must delve into how to identify hazards and prevent accidents. Identifying hazards. Before any primary line activity, a visual and technical inspection walkthrough must be done. Main hazards can be nearby energized conductors, or branches or metallic objects, poles or towers with structural deterioration, electrical equipment with damaged insulation, adverse weather conditions, rain, wind, and humidity, presence of third parties in the work area. Each hazard must be recorded and assessed, determining its likelihood and severity. Risk assessment requires more than just identifying hazards. It is necessary to evaluate associated risks, low probability, medium or high consequence, mild, moderate, severe priority level low, medium, high. Critical, right? For example, this hazard, a fallen branch on a conductor. Medium probability forest area, severe consequence. Possible electrocution. High priority, apply strict preventive measures. Now, there are prevention techniques. Active prevention are actions before starting the activity. De-energize lines whenever possible. Use tools and equipment with certified insulation. Mark and limit work zones. Coordinate with supervisors and support staff. Passive prevention. Wear elements reduce damage if an accident occurs. Complete and well-maintained personal protective equipment. Harnesses and lifelines for working at heights. Insulating boots and flame-resistant clothing. During a maintenance shift, a technician detected an unstable branch above a conductor. He applied active preventive measures, marked the zone, coordinated with the supervisor, and removed the branch with insulating loss. What was the result? Task completed without incidents. Now, there are human risks. Human error is one of the most common factors in electrical incidents. Overconfidence, fatigue or distraction, lack of training or experience, pressure to meet deadlines, strategies to mitigate human errors, constant training, procedures and protocols, active brakes to reduce fatigue, effective supervision, and peer support, feedback. Post-activity to identify errors and correct them. There are safe work procedures. Specific steps must be followed for each activity. Verify that the line is de-energized, or apply live work procedures. If necessary, check tools and equipment. Inspect the area and remove obstacles or hazards. Apply signage. Define work zones. Coordinate with supervisors and coworkers. Continuously monitor environmental and electrical conditions. An example could be that during pruning near a live line, a team applied a procedure. They checked voltage, placed signage, used complete equipment, maintained constant communication, and the activity was carried out without incidents. The always expected outcome. This requires preparation and planning. Planning not only means preparing tools and equipment, but also anticipating unexpected risks. Analyze weather, terrain, traffic, and site conditions. Determine necessary human and material resources. Establish evacuation routes. Document risks and control measures in the prior risk analysis. Planning is not a luxury. It is a critical element for safety and efficiency. An extra minute of review can save a life. This also requires supervision and follow-up. Effective supervision ensures safety measures are followed. Continuously observe task execution. Detect deviations and correct them immediately. Ensure all team members follow protocols. Encourage discipline. Attention in every maneuver. A supervisor noticed a technician handling tools on a connected lifeline. Intervened immediately, prevented a possible fall, and strengthened team discipline. There are also case studies about learning. Learning from past incidents is essential, right? Because a technician suffered minor burns. From electric arc for learning purposes. Always use a face shield. A faulty tool caused an object to fall. Learning to inspect tools at the start of each day. The supervisor missed this. Checking voltage is a learning point. Review protocols. Before starting any activity, each case reinforces the importance of prevention, discipline, and a safety culture. Now, there's planning and work permits. Planning and work permits are essential pillars for safety in primary line maintenance. Every technician must understand that improvisation can be deadly and that every activity requires preparation, analysis, and formal authorization. There must be prior planning before starting work, before any intervention. There should be a site inspection. Walk through the area to identify visible hazards such as branches, wires, damaged poles, unstable ground, nearby traffic. Check weather conditions, rain, humidity, wind, and temperature. All of these directly affect safety and maneuverability. Activities should be postponed if conditions are adverse. Verify resource availability. Make sure all tools and equipment are in good condition and available to personnel. Evacuation routes. Define safe paths in case of emergency, considering heights, obstacles, presence of third parties. Simulate critical maneuvers. Anticipate movements, positions. Coordinate team members for each task. Right? During a maintenance shift in a rural area, a supervisor conducted a detailed inspection and detected that a branch could interfere with the line. Thanks to the planning, The branch was removed before climbing the pole, avoiding a potential accident, right? Now, regarding work permits. These work permits are documents that formalize authorization to carry out high-risk activities. This includes a detailed description of the work to be done, identification of the personnel involved, risk assessment, control measures, required environmental and safety conditions, emergency procedures, and contact information for those responsible. There are types of permits. Working at heights, required for maneuvers on poles or towers. Working on energized lines requires special authorization with certified personnel and strict procedures. Work with special tools or machinery includes saws, cranes, poles, chainsaws. A work permit is not just a formality. It is a risk prevention and control tool that protects personnel and ensures the activity complies with rules and protocols. So there are step-by-step procedures to guarantee safety and compliance. A well-structured procedure must be followed. Initial preparation, check equipment, tools and materials, verification of absence of voltage, measure and confirm the line is de-energized, and apply safe procedures for hot work. Delimitation of the work area. Place signage, cones, physical barriers to protect third parties and personnel. Role assignment, define who climbs, who supervises, who controls safety on the ground. Execution of the task. Handle tools, perform pruning. Installation or maintenance, strictly following protocols. Constant monitoring. Maintain communication among all members. And monitor risk conditions throughout the entire activity and work closure. Remove tools. Verify that the area is safe. Complete reports. Update permit and risk analysis records. The team performed maintenance on an urban line. While the supervisor followed each step of the procedure, the absence of attention was verified, limited to ARI. Clear roles were assigned and constant communication was maintained. The work was completed without incidents and within the estimated time. The most important thing is this, with nothing to regret. Now, there are risk matrices. Risk matrices are tools that allow visualization, prioritization, and control of identified hazards. The key element, identified hazard, contact, electrical, fall. Defective tools, probability of occurrence, low, medium, or high. Impact or consequence, mild, moderate, severe, critical, control measures. Preventive and corrective actions. One must analyze risks before working. This allows anticipating problems, distributing responsibilities, and prioritizing preventive actions. Now, coordination with supervisors and authorities is necessary. Every intervention requires coordination with safety chiefs and authorities. Local when working in urban areas or roads. Inform traffic authorities if a street is blocked, and coordinate with neighbors or local or area security personnel. Record the activity in the official logbook and safety management system. Maintenance of a line in an urban area. Coordination with local police enabled. Traffic control and limiting the work zone. Preventing accidents with pedestrians and vehicles. Then, feedback and continuous improvement after each workday. Hold feedback meetings with the entire team. Identify errors, successes, improvement opportunities, update procedures and risk matrices. Based on observations, record minor incidents or accidents that have occurred for learning. A team reviewed a pruning accident. It was found that a technician had not properly secured the insulating loss. After feedback, the procedure was updated and training was reinforced, reducing future risks. In future shifts, planning and work permits are more than just papers or forms. They represent a risk prevention strategy, ensuring that each team member has clarity about their role and responsibilities. They allow documenting and standardizing procedures, creating a strong and consistent safety culture. Right? A minute of planning can save a life. A correct work permit can prevent an accident. Sometimes it's critical. Now, as I said, there must be communication, coordination with supervision. Safety in primary line maintenance does not depend solely on technical knowledge or personal protective equipment. Effective communication, team coordination, and constant supervision are fundamental pillars to prevent accidents and ensure the success of each task. Now, the importance of communication. Clear and continuous communication prevents errors, confusion, and accidents. Essential aspects of communication: clarity in instructions. Each member must understand their role in the specific actions they must perform. A confirmation of receipt. Ensure the message was received and understood, especially in critical situations. Standardized language. Use technical terms and universal signals to minimize misunderstandings. Constant reporting. Report changes in conditions, detected risks, or any unexpected situation. During pruning on a line, the height technician pointed out an unstable branch thanks to clear communication. The ground team reacted, removed obstacles, and prevented a possible accident, right? Now, team coordination for work on primary lines involves synchronized actions between several technicians. Coordination ensures everyone knows what to do, and when to do it, there is no task overlap that could cause risk. A minimum safety distance is maintained. Reaction times to environmental changes are respected. There are common roles in a height technical team: safety supervisor, ground support, who manage the tools and control the environment through communication. There is a signal officer, responsible for traffic, who ensures no third parties are in the risk zone. A team working in an urban area carried out the installation of a transformer while coordinating with traffic and neighbors. The synchronization between roles allowed completion of the task without interruptions or incidents. Visual signals and communication in height work and noisy areas. Verbal communication can be limited. Therefore, standardized hand signals are used. Emergency signals: stop work immediately. Movement signals: raise or lower tools, adjust position. Attention signals: alert about nearby risks, such as electric arc, falling objects. It is necessary to practice drills. This strengthens coordination and reduces risk in real situations. Now, there must be effective supervision. Supervision is the most powerful control tool to prevent incidents. Key functions of the supervisor: checking protective equipment, tools, ensuring everything is in optimal condition, monitoring the procedure, making sure each step is followed according to protocol. Real-time risk identification, detecting and correcting deviations before they become incidents. Support and feedback, guiding the team and reinforcing good practices. During rural online maintenance, the supervisor noticed a technician who had incorrectly installed the lifeline, intervened and fixed the situation, preventing a potentially serious fall. Right? Therefore, there should be meetings before and after each workday. Brief meetings allow reviewing the work plan, analyzing risks, control measures. There must be a talk, ensuring everyone understands the procedures and roles, discussing previous incidents and lessons learned. These meetings should be participatory, encouraging questions and clarifications for the whole team. Next, coordination with other departments is necessary. In primary line work, interaction with traffic is often required. Road safety in urban areas. Road maintenance when lines cross roads. Local authorities, rural communities, other electrical teams to cut or redirect power. A team coordinated with a local authority to temporarily unblock a street while replacing a transformer. Thanks to planning and coordination, the activity was completed without incidents and in record time. Coordination must exist. Then, after this, there's a communication tool to ensure communication is effective. Two-way radios or walkie-talkies are used. Standardized visual signals. Emergency alert systems, such as sirens or lights. Checklists and written forms. Always verify that the radio and communication system are operational before starting work, that batteries are charged. Then, there must also be coordination in emergency situations, including planning. Incidents can happen. Coordination is key to responding effectively, staying calm and following emergency protocols, activating communication lines with supervisors and medical services, safely evacuating those involved, documenting the incident for future lessons. During an accidental arc flash, the team applied the emergency plan. They evacuated the affected technician, cut off the power, called emergency services, and thanks to that coordination, the incident had no serious consequences. It's true. There was always good coordination. Now, close to feedback and learning. Supervision also includes post-work analysis, reviewing whether all safety steps were followed, analyzing deviations, how they can be corrected, strengthening the safety culture through practical examples, documenting both incidents and best practices, strengthens future prevention. So now, communication, coordination, and supervision are as important as technical knowledge because they ensure the team acts in sync. They allow detecting risks in time and applying preventive measures. They strengthen the culture of safety and discipline. A team that communicates and coordinates effectively. A team that returns home safe and sound. There are real cases and lessons learned. In the field of primary line maintenance, each accident or incident becomes a lesson to improve safety. Analyzing real cases allows identifying errors, failures in procedures, and these are opportunities for prevention, strengthening the safety culture. Therefore, the importance of learning from incidents is that electrical incidents rarely happen by chance. They are usually the result of human errors. Overconfidence, distractions, fatigue, carelessness. Tool failures or defective or worn equipment. Procedures not followed, skipping steps. Due to hurry or carelessness, adverse environmental conditions, rain, wind. Humidity benefits of incident analysis, causes are identified. Protocols and procedures are adjusted. Staff training is strengthened, future accidents are prevented. So 4. Example, a case of an electric arc during pruning of A. Line A technician was pruning near a live line. Without properly using the insulated pole, what does this cause? Lack of prior voltage verification, excessive confidence from routine. Also, insufficient supervision at the critical moment. And this leads to consequences. An electric arc that caused a minor burn. Temporary power outage. So, what is the lesson learned here? Always verify the absence of voltage, even in routine work. Maintain constant communication among the team. Strengthen supervision on critical tasks. So, there is another case, a fall due to a poorly fitted harness. The situation was that during maintenance at height, a technician slipped because the harness wasn't properly adjusted. The cause of this: personal protective equipment used incorrectly. Lack of a detailed inspection before climbing that causes this. Minor injuries without fatal consequences, thanks to the secondary lifeline. Lessons learned: always inspect and adjust the harness and lifeline. Continuous training on the proper use of personal protective equipment. Never underestimate the height or the importance of safety elements. There was another case of a defective tool, in which a technician used a tool with external insulation. When it touched the conductor, it generated an electric arc. And the cause of this was the lack of prior inspection of the tool. Lack of awareness of equipment wear. And what did this cause? What were the consequences? Minor burns on the technician's hand, damage to the tool, loss of time during the shift. In the lesson learned: inspect tools before each shift. Keep a record of service life. Insulation tests. Reinforce a culture of responsibility regarding one's own personal protective equipment and tools. Another case involved a lack of signage in an urban area. During a line maintenance, cones or barriers were not placed to delineate work zones. What does this cause? The lack of prior planning. Lack of knowledge of traffic safety procedures. And what were the consequences? Risk of pedestrians being struck. Distraction of technicians due to the presence of third parties. What is the lesson learned? Always demarcate the work area. Coordinate with traffic authorities and security personnel. Integrate third-party safety into the work plan. Therefore, there must be an analysis of human factors. Studies show that most accidents on primary lines are related to human factors, more than technical failures. Common factors include routine, overconfidence, fatigue, workload, and prolonged. Lack of attention to signals and warnings. Poor communication. Mitigation strategies. Could be active breaks and scheduled rests. Constant supervision, role rotation. Then, remember risk procedures. Recording and analyzing accidents for collective learning. Another point is simulation and training. Simulating accidents and risk scenarios allows preparing the team for real situations. Arc flashes, falls from heights, contact with energized lines. Medical emergencies on site. And what are the benefits of this? It strengthens muscle memory and quick reactions, reduces anxiety and mistakes in real situations, promotes discipline, coordination between teams. So, during an arc flash simulation, some technicians learn to assess the affected colleague, cut emergency power, and report the incident to the supervisor, strengthening the team's actual safety. Then, another important point is documentation. And continuous learning from each incident should be documented in detail: date, time and place of the event, description of the incident, contributing factors, actions taken, and outcomes. Recommendations to prevent recurrence. That is, keeping a historical record helps identify risk patterns and continuously improve procedures. The learning culture. A culture of learning from incidents must be adopted. It promotes individual and collective responsibility and encourages continuous improvement of procedures and protocols, reinforces the importance of safety during an emergency or work pressure, encourages open communication and constructive feedback. Every accident is a lesson. Every lesson saves future lives. Therefore, analyzing real cases is not about finding blame, but about learning and preventing. Safety depends on preparation, discipline, and a culture of prevention. Lessons learned turn experience into practical knowledge. Each team member must take responsibility for applying what they've learned. Reinforcing safe habits in every home. Experience teaches. Mistakes prevent and discipline protects. So, we've traveled a complete path. From the basics of safety, through electrical risks, protective equipment, personnel, planning, certification, work permits, communication, coordination, and incident analysis. And now, all that we've learned will help us strengthen our discipline. Preparation and safety culture when working with primary lines. Safety as an absolute priority. Working with primary lines is a high-risk task. Every decision, every action, and every procedure have direct consequences on the lives of technicians and their coworkers. So, there are key points to remember. Electricity is invisible but deadly. No work justifies risking life. Safety is both an individual and collective responsibility. An experienced technician recalled that during his first year, he made a mistake by underestimating the safety distance. Fortunately, constant supervision prevented a serious accident. That experience strengthened his commitment to procedures and communication within the team. So, discipline must be remembered. Discipline is not just about following rules, but also about consistently maintaining safe habits. It is important to always check equipment of personal protection, and tools before use. Follow procedures step by step. Report any anomaly without delay. Take the necessary time, even if the task seems urgent. During a maintenance shift, a technician detected a tool with worn insulation. Thanks to the discipline of checking every component before climbing, the tool was replaced and a potential accident was avoided. Safety culture is not imposed either. It is built day by day. Every safe decision reinforces habits across the team. Constant feedback strengthens prevention. Documentation of incidents and lessons. Learn creates collective knowledge. Example of leaders and supervisors motivates the team to follow protocols. When everyone considers safety a priority, accidents decrease and efficiency rises. Safety and productivity are not opposites. They complement each other. It should always be that way. So, to consolidate all the learning from this video, it is useful to review the main concepts. Electrical hazards, direct contact, indirect contact, electrical arcs, weather conditions, and human errors. Safe work principles, minimum distance. Working with de-energized lines. Verification of the absence of voltage. Established procedures. Constant communication. Personal protective equipment, helmet, gloves. Safety glasses, flame-resistant clothing, electrical boots. Harness and glass fiber lines. Planning and permits. Site inspection. Risk assessment. Work permits, clear roles. Zone delimitation. Emergency analysis, communication, coordination, signals. Coordination with supervisors, authorities, radios, alerts. Emergency protocols. Real cases and lessons learned. Analyze previous incidents. Identify causes and routes. Document and explain improvements. Recommended practical exercise. Before starting each shift, mentally review each of these points and apply a complete checklist. This practice reinforces habits and prevents forgetfulness errors due to routine or fatigue. Then, work safely. Safety requires personal commitment. Each technician must take responsibility to protect their own life and their coworkers' lives. Follow the rules and procedures, with no exceptions. Report risks, incidents, and unusual situations. In an incident where a branch fell on the line, a technician warned the team before climbing, avoiding contact with a live conductor. This action shows how personal commitment can save lives. Now, simulation and continuous practice. Knowing or hearing is not enough. Constant practice is crucial. Conduct simulations of common incidents. Practice step-by-step procedures. Strengthen communication, coordination, and supervision in each exercise. Evaluate performance and immediately correct errors. Each simulation must be documented and analyzed, as if it were a real incident to maximize learning. Now, working with primary lines requires professional ethics and moral responsibility. Your own safety is priceless on the agenda.